Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces.
Today, we're diving into the world of artificial intelligence and medicine. Imagine you go to the doctor, they run a scan, and an AI not only spots the problem, but then sits down and explains everything to you, just like an expert physician.
That's the dream, right? To have AI that doesn't just find answers, but can actually communicate and reason about them. And that's exactly what a new paper called DL3M, a vision-to-language framework for expert-level medical reasoning, is all about.
It sounds pretty futuristic. So what's the problem they're trying to solve? Don't we already have AI that can read medical scans?
We do, but there are different kinds of AI, and they don't always talk to each other. On one hand, you have what's called deep learning models. These are fantastic at image recognition. You can show one thousands of medical images, and it gets really good at classifying them. It can look at a new image and say, that's a polyp, with high accuracy.
Okay, so it's a great diagnostician. What's the downside?
The downside is that it's a black box. It can't tell you why it thinks it's a polyp. It just sees patterns in the pixels that match patterns it's seen before. It can't explain its reasoning.
Ah, so it has the what, but not the why. So where do the language models we hear so much about, like ChatGPT, fit in?
Exactly. That's the other side of the coin. Large language models, or LLMs, are brilliant at generating text and explaining complex topics. But you can't just show an LLM a medical scan and ask it for its opinion. It works with words, not images.
So we have one AI that can see but can't talk, and another that can talk but can't see. And this paper is trying to get them to work together.
Precisely. The researchers created a framework they call DL3M. Think of it as a two-step process to bridge this gap. Step 1 is the vision part. They built a custom deep learning model to look at endoscopic images.
Those are the images from the tiny cameras they use to look inside the stomach and intestines, right?
That's the one. Their vision model, which they named Mobile CoatNet, analyzes an image and makes a diagnosis. It might say, this is esophagitis, which is inflammation, or this shows a healthy pylorus, which is a part of the stomach.
So it does the initial diagnosis. What's step 2?
Step 2 is the language part. The system takes the diagnosis from the vision model, just the word, like polyp, and feeds it as a text instruction to a large language model.
So it's basically telling the language model, hey, we found a polyp. Now pretend you're a doctor and explain what that means.
Exactly. The prompt they use is very specific, something like, an image has been identified as a polyp. You are an experienced gastroenterologist. Explain the probable causes, symptoms, treatments, and lifestyle changes for a patient. The LLM then generates a full, detailed clinical narrative.
That's a really clever way to combine their strengths. But how do you test if the explanation is any good? It's not a simple right or wrong answer.
And that's the heart of this study. First, they had to make sure their vision model was rock solid. They tested it on a dataset of 8,000 images and found it was over 97% accurate, which is fantastic.
Okay, so step 1 is reliable, but what about grading the LLM's essay?
They had to create their own answer key. They built what they call gold standard benchmarks. This involved having actual human medical experts write down the ideal comprehensive answers for all the different stomach conditions, covering everything from causes and symptoms to lifestyle advice and follow-up care.
So they had a perfect answer sheet written by humans. Then they tested the AIs against it.
Yep. They tested 32 different LLMs, including models from the GPT series, Gemini, and others. They gave them the diagnosis and compared the AI-generated explanations to the expert-written ones.
So the million-dollar question, did it work? Is this the future of medicine?
Well, the results were fascinating and a bit of a reality check. On one hand, yes, it worked. When the vision model made the correct diagnosis, the best LLMs were able to produce incredibly useful and well-structured clinical explanations.
That's a huge success. It proves the concept can work.
It does, but there's a massive catch. The entire system is extremely fragile. The final explanation is only as good as the initial diagnosis.
Oh, I see.
If the vision model makes a mistake, the LLM has no idea.
None at all. If the vision model wrongly identifies a healthy piece of tissue as a polyp, the LLM will confidently and eloquently generate a completely wrong and potentially dangerous explanation about how to treat polyps. It's the ultimate garbage in, garbage out problem.
That's a pretty serious flaw. What else did they find?
They found that not all language models are created equal. The bigger, more advanced models were far more stable and consistent. But the most important finding was this: even the very best AI did not reach what the researchers called human-level stability.
Meaning they're still not as reliable as a real expert.
Not even close. None of the models were deemed reliable enough to be used in a real medical setting without direct human supervision. The researchers classified the top performers as adaptive, meaning they're competent but need watching, while the rest were simply unreliable.
So what's the big takeaway from all this?
The takeaway is that this paper gives us a brilliant and very realistic roadmap. It shows us that the idea of combining a seeing AI with a talking AI is a powerful path forward for making medical AI more transparent and useful.
But it also serves as a critical warning. These systems are brittle. They are not ready to make high-stakes decisions on their own. One small error at the start can lead to a huge, convincing-sounding mistake at the end.
Exactly. This isn't about replacing doctors. It's about building better tools to help them. This study shows us how these tools could one day work, but more importantly, it shows us all the work left to do to make them safe and reliable.
It's a step towards an AI that can not only find the needle in the haystack, but also tell you what kind of needle it is and what to do with it. A fascinating piece of research.